So let's look at some of these problems. What is the slope of the tangent line to the curve at this point? Okay, slope. When you see slope, what does your brain need to think? Derivative. Your brain needs to think derivative. So here we have a nice curve. The cube root of x plus the cube root of y squared at equals 7. Sorry, that's some curve. So we need to take the derivative of this. So we're going to do this with our implicit derivative knowledge. Okay, implicit derivative knowledge. Because we have an x and a y. This would be a pretty murderous thing to solve this for y. Right? So rather than solving it for y, we're going to do implicit differentiation. So x to the 1/3 power plus y to the what power? 2/3 power equals 7. So I'm just rewriting it as a polynomial in case you forgot how to take the cube root derivative, which is possible, right? We don't do a cube root derivative every day. So what is the derivative of x cubed? X to the 1/3. We bring this to the front. Good. 1/3 times x to the negative 2/3, right? We subtract 1 from our power. Plus, the same thing for our y. We bring the 2/3 to the front. Y to the negative 1/3 power times y prime, or dy dx. Okay, you can write it as dy dx if you want to use some more ink or graphite or whatever you have. And then the derivative of 7, our constant, is just 0. Okay? And of course we want to solve this for y prime. We want to solve this for y prime. Okay? So the first thing we're going to do is move our x coordinate over to there. Right? And maybe you want to rewrite that as, as not a fractional power or something. So if you want to do that, it becomes 1/3, right? There's your 1/3 part. And it's the 3rd root of x squared. Okay, the 3rd root of x squared. Your denominator in your fractional power becomes your radical, right? So it's the 3rd root, and your numerator becomes your exponent. So 1/3 of x to the negative 2/3 simplifies to 1/3 times the 3rd root of x squared. Okay, so we can do the same thing over here, right? That would be a 2 in your numerator times 3 times the 3rd root of y. Okay, so that's our 2/3 of y to the negative 1/3 simplified. Our negative power means that it goes in the denominator of our fraction. So it's a positive 1/3 in the denominator, and then we rewrite that positive 1/3 as a 3rd root. And I multiply that by y prime. Okay, now if we were going to be solving this for reals, right, if we wanted to really take the derivative of this and write it as a single fraction, I would multiply by the reciprocal. So I would multiply by 3 times the 3rd root of y over 2. Both sides multiply by the reciprocal if I wanted to solve this for y prime, right? AKA dividing. But dividing by a fraction, right, that doesn't really come out to be a very good thing. A fraction divided by a fraction. So what we're actually doing is we're multiplying by the reciprocal. So if we look on the right side, what things can divide out? The 3 in the numerator can divide out by the 3 in the denominator. So I just have the 3rd root of y in my numerator. And in the denominator, I have a 2, right? The 2 comes from right here. And a 3rd root of x squared. So if you had to simplify and solve for y prime, that would be the simplification. Okay, but we probably could have stopped way back here and that would have been okay, because now we want to plug in what number? We want to plug in 27 for x and 8 for y. Okay, so if you want to figure out what the derivative is, well, we just found the equation to find the derivative at any point. So how about at the point 27 comma 8? So that means our y value is 8 and our x value is 27. Okay, now without a calculator, this can be pretty tricky. Okay? If this were an FRQ problem, that would be good enough. You could stop right there. You do not have to simplify this if it is a free response question and they want you to find the value. You have done exactly what calculus wants you to do. Found the derivative and substituted. But we're going to actually find that number so we can practice our simplification. Okay, on top, what is the cube root of 8? It is the real number 2. Now, here's the tricky part that we can do on the bottom. Okay, so the way that cube roots and powers work, the cube root of 27 squared is the same thing as the cube root of 27 squared. Okay, now I don't know what 27 squared is, and I definitely don't know what the cube root of that is, but I'm pretty sure I know what the cube root of 27 is. Right? That number is 3, because 3 times 3 times 3 is 27. And 3 squared is just 9. Right? That's one of these algebraic things that we can do, is you can take your root and your power and you can evaluate them in different ways. Okay? Whatever way is most convenient for your brain. Right? If we had a calculator, it wouldn't matter, but our brain matters. I've just been informed that I am missing a negative, so we'll put that back in. So the answer is going to be negative. 2 divided by 2, well, that's a nice one. 2 divided by 2 is 1, so my final answer is negative 1 over 9. Okay, that is a lot of math right there, a little bit of calculus, and a whole lot of algebra. Okay, we're skipping down to number 5 here. Here we have our function, cosine squared of 2t, and we're looking for the first value on your unit circle, so we're going to look at our unit circle values and see when is this first one. What's the one closest to 0 where the derivative is 0? Okay, so first we have to find the derivative equation. So let's go ahead and find the derivative. S prime of t. Okay, so I like to, whenever I see a power in my trig, I like to move the power to the end, because this helps me see the different things I need to do for the chain rule. Okay, because there are how many functions of cosine of 2t squared? Right, you notice that there are 3 functions. The first thing is a squared function. The second thing is a cosine function, and the third thing is a 2t function. So there are 3 things that I have to take the derivatives of, one at a time, starting with the outside-most thing first. So first I take the 2 from my power and move it to the front of my equation. So 2 times the cosine of 2t raised to the first power, right? So we don't have to write a 1 up there, but 2 minus 1 is 1, so raised to the first power. Now I'm going to take the derivative of my cosine. So the derivative of cosine is negative sine. And my argument doesn't change. I still have my 2t in parentheses. The derivative of cosine of 2t is negative sine of 2t. Right, the angle part hasn't changed. But now we're down to our last derivative. What is the derivative of 2t? Well, that is a 2. Okay? So that is a chain rule, right? Anytime we have a trig, we're going to be using a chain rule derivative in order to do that. So a little bit of simplification. I have a 2 times -1 times 2 is -4 cosine of 2t times sine of 2t. And I want to know, when is that going to be equal to 0? So now let's use our algebra skills. Our first going to divide both sides by -4. Let's get rid of that. That doesn't change 0, of course. So cosine of 2t times the sine at 2t still equals 0. Okay? So now we're going to go back to our Algebra 2 knowledge. If I have two things that multiply together to give me 0, right, by the zero product property, either the cosine, our first thing has to be 0, right, because 0 times something is 0, or the second term has to be 0. One of those two things must be 0 in order for the product of them to be 0. Right, so we do this in algebra all the time when we have a quadratic. We factor the quadratic and set each of your terms equal to 0. Well, this is no different. These are factors because they're being multiplied together. Multiply means factor. Okay, so let's solve. First, we take the inverse trig. Right, so 2t equals the inverse cosine of 0. Okay, so that's our first thing, is to move the trig. So this is asking us, what is the angle where cosine is 0? Right, what is the angle where cosine is 0? The first one is pi over 2 at 90 degrees. And the second one is 3 pi over 2, or 270 degrees. So there are two places on your unit circle where the cosine is 0. So we have two equations to solve, right? Double the equations. So if I divide the first one by 2, that's the same as multiplying by a half. I get pi over 4. And if I do the same thing, divide by 2, aka multiply by a half, I get 3 pi over 4. So those are my two solutions if cosine is going to be the 0. Okay, I have pi over 4, and I have 3 pi over 4. So out of these two, pi over 4 comes first. Right, on the unit circle, 45 degrees is before 135 degrees. So let's see if our other equation, sine of 2t, gives us something before pi over 4. So we'll do the same thing. We want to figure out where the sine of our angle is 0. Where is that going to happen? 0 and pi, right? So looking at our problem, right, it says 0 is not an option, so we can't use 0. 2 pi is also not an option. Right? It doesn't say or equal to, so we're not looking for a 0 angle or a 2 pi angle. So the only place where sine is 0 is at pi, because we can't use either one of our two endpoints. We can't use 0 radians, nor can we use 2 pi radians. So we can only have pi. That's the other place on your unit circle where sine is 0. And dividing both sides by 2 means I have an answer at pi over 2. So there are three places. But what's the closest one to 0? What's our smallest angle? Pi over 4 is your smallest angle. So that's going to be your answer. Right? There is a lot of pre-calculus in that one. A lot of pre-cal. Okay, number 7 is the derivative of an exponential. So we always use a chain rule with the derivative of an exponential. Okay? So the derivative of an exponential is always itself. Always itself. So the derivative of e to the 3x squared is e to the 3x squared times the derivative of its power. So what's the derivative of 3x squared? 6x. Okay, so chances are you're more likely to see this written in its correct form. So the algebra comes first, and then our exponential stuff comes second. Okay, number 8 wants an equation of a tangent line. So we need to know two things when we're writing an equation of a tangent line. The y value, what is the y value of that point, and what is the slope. And anytime we see slope, we need to think derivative. So the y value is just what I get when I plug 4 into my equation. Plug 4 into your equation, right? Into your straight up function, just as they give you. So that's the natural log. The square root of 2 times 4 is 8. 8 minus 4 is 4. What's the square root of 4? 2. So this is just the natural log of 2, right? Which is a perfectly wonderful number. That is a nice decimal that we don't care about. The answer is the natural log of 2. Now, let's go on to our derivative. The derivative of a natural log function is always going to be a chain rule. So we have 1 over the argument. So 1 over the square root of 2x minus 4. Right? That's the natural log part. 1 over whatever the argument is. Now to finish off, we have to find the derivative of our argument. This is the chain rule portion. So what is the derivative of square root of 2x minus 4? Well, if you've memorized your square root derivative, that's 1 over 2 times itself. Right? 1 over 2 times itself times the derivative of what's underneath your radical, which is just 2. Okay? So we have to use a chain rule with our radical, with our square root. Okay, so this part is the derivative for the square root of 2x minus 4. All of this is the derivative of 2x minus 4 under a square root. This is your natural log derivative. The rest of that is the chain rule for square root. Okay, so right away, what can we simplify? This 2 can divide out with that 2. Oh, and I have 1 over a radical times 1 over the same radical. So anytime I have a radical times a radical, that's just no longer a radical. Well, that's pretty handy. So this is our derivative, 1 over 2x minus 4. Okay, because root 2x minus 4 times root 2x minus 4 is regular old-fashioned 2x minus 4. So now when I plug x equals 4 in here, what do I get? I get 1/4. So that's my slope. My slope is 1/4. So now that I have my slope and I have my y value, I can write my equation. Y minus the natural log of 2 equals 1/4 times x minus 4. Okay, and now our implicit. We want to find dy dx, so this is our implicit derivative. So take them one at a time. The derivative of x cubed, that's just 3x squared plus 3. Okay, we're going to pull the 3 out and use the product rule to find the derivative of x squared times y. So we're going to use the product rule on x squared y. Okay, so pull the 3 out. So product rule says the first thing times the derivative of the second, which is just y prime. Anytime we're taking a derivative of y, you always have a y prime. In this case, 1 y prime, because the derivative of y is 1. Plus the derivative of x squared, which is 2x, times the second term y, equals the derivative of a constant is 0. Okay, so now we're going to distribute our 3. We're going to multiply both of these things by 3 again, right, to get it back to where it doesn't have any parentheses. 3x squared y prime plus 6xy equals 0. Okay, now our job is to solve for y prime. And y prime is right here, multiplied by 3x squared. So I'm going to take all my stuff that doesn't have a y prime in it and subtract it to the other side of my equal sign. Okay, so I'm taking all the stuff that's not y prime, and I am subtracting it to the opposite side. So it's a minus 3x squared and a minus 6xy. And now let's divide by 3x squared. So let's see what we can simplify here. Even though on an FRQ you don't have to simplify, let's see what we can do. So I notice that each of these terms has a multiplier of 3. So I'm going to divide them all by 3. So 1, and then this is going to be a 2, and then a 1 on the bottom. And each of the terms also have an x. So I'm going to divide them all by x. So my most simplified answer, negative x minus 2y, all divided by x. Right? That is as simple as our derivative can be. Okay, but once again, it's okay if you stop here, because that is also AP correct. So now we're looking at a tangent line equation. Oh, they already gave us the x and the y. All we have to do is find the slope. And I have the equation for that right here. So it's the negative of 2 minus 2 times negative 2, right? That's the y value over 2. So this is my x, this is my y, this is my x, right? So I'm finding my slope. Every tangent equation needs a slope and a y value. So this is negative 2 plus 4 divided by 2, which turns out to be 1. So our graph has a slope of 1. Okay, now if you wanted to be extra, you could write that in there. So y plus 2 equals 1 times x minus 2. Right? If you wanted to be extra, you could write the 1 in there. But of course, you don't have to. So our last thing is to find the second derivative. So we start with our first derivative, which was the negative of x minus 2y, all divided by x. So this is going to be a quotient rule derivative, right? Because we have a fraction, quotient rule derivative. So y double prime equals low times the derivative of the high thing. So the derivative of x is negative 1 minus 2y prime. Right? The derivative of y is always a y prime, and those are both being subtracted. Minus the high term, which is negative x minus 2y, times 1, the derivative of your denominator, all divided by denominator squared. Okay? So there's one thing to do, and that's replace y prime with its fraction that we came up with up there. Okay, so that's our last thing. Y double prime is x times minus 1 minus 2, and then we have our fraction minus x minus 2y over x. Right, there's your y prime. There's your y prime. Plus x plus 2y, so we'll just go ahead and change this to a plus. I don't like minuses. plus x plus 2y all over x squared. Okay, and on an FRQ, y'all, that is good enough. On a multiple choice, yes, you have to go and simplify that all the way down.